Okay, ladies and gentlemen, we are starting Unit 7, and that is about rational expressions and equations. When you think of the term rational, you should think of somebody who's very under control. No, that's not really the rational we're talking about here. When we're talking about rational, we're actually talking about, we're referring to like fractions, basically. Okay, a rational expression is a fraction. Okay, however, the fraction basically means that you have one number or one term divided by another term, right? Okay, or in this case we have some form of expression or polynomial divided by another polynomial, okay? And so right here when we talk about defining a rational expression, you're talking about a quotient, okay? It says right there on page 1 of Unit 7 notes, a quotient, which means divide, of two polynomials, okay? So we're going to divide two different polynomials, and that's the bottom line. All right, so a little example of what we have there. They have it there in the notes. They put x squared. My little stylus isn't working very well. X squared plus 3x minus 10 over 3x plus 2. Okay? And basically that's a rational expression. It's a polynomial or a trinomial divided by a binomial, right? And if you remember back, we've talked many times about fractions being what? Fraction just means to divide. So you could actually rewrite that if you wanted to as x squared plus 3x minus 10, all of that divided by 3x plus 2. Okay, so these two things basically mean the exact same thing. Okay, just written in different forms. Okay, and if you look at the term that we started with, right, the whole title of this little video, simplifying rational expressions, okay, you should be taking a couple different things from those three words. First of all, simplifying. Okay, when have we talked about simplifying? Okay, usually when we're talking about fractions, right, we say make sure your answer is simplified or in the simplest form. Okay, and that means to reduce. Okay, and then you have rational, which is we're talking about the fraction, and then an expression. In this case, that just means there's no equal sign, right? An expression means no equal sign. So, I mean, that's really what you're doing. You're going to reduce this thing down until you can't reduce it anymore, and that's the bottom line. Okay, so if you keep looking through your notes, you have different examples of rational expressions. Okay, like for the number 1 there. It says 5 over x, okay, where x is not equal to 0, because if you had 0 in a denominator, that's going to give you an undefined, right? You can't divide 0 into a number. And then like for number 2, you have a over b minus 2, and it says where b cannot equal 2, and that's because, again, it'll put 0 in the denominator. Okay? All right, so here is the bottom line with what we're doing. We want to simplify these expressions that we're going to get, okay? And now sometimes you cannot simplify things. So that, like the example they give you a plus 2, that's very poorly written, a plus 2 over 3a. Okay, now that is in simplest form. You can't do anything about it, okay? The a plus 2 can't be factored or anything like that, so you're just done. Okay, however, if you have something like this, okay, 5 times the quantity x plus 4 over x times the quantity x plus 4. Okay, you could actually break this into two different parts, right? You could do 5 over x and then times x plus 4 over x plus 4. And look at that, x plus 4 over x plus 4. What is anything over itself? That just means 1, so that goes away. So your answer is just that 5 over x. Okay, well that's really what we're going to be working on, right? We're going to be breaking things into their factors. Excuse me. And then you're going to find any common factors that you can. And then once you find common factors, you will reduce those or simplify them. Okay, and then the last part, it says basically we're not going to make the denominators equal 0, because if we do that, then that messes the whole thing up, right? All right, so let me go to a new page here and we can start working on something. All right, so the first one we have here, It says 5x minus 10 over 5x. Okay? Now, what you want to do here is you just want to factor. Okay? And if you look here, we can factor that top, right? The 5x minus 10, you can pull out a 5, right? So you get 5 times x minus 2. And on the bottom, you have 5 times x, right? Or just 5x. Okay, well, if you look, you can reduce the 5 and the 5, right? Because now they're both factors. So 5 and 5 reduce to 1, 1. So our answer is going to be x minus 2 over x. There's your answer. And that's as simple as this gets, okay? It's just like reducing fractions. Okay, let me give you an example of a fraction and how you do this, right? So if we had like, say 12 over 8, right? Okay, well, you know right away that you're going to divide those by 4 and you'll get 3 over 2, right? Okay, well, let's just make it a little more algebra looking. Instead of doing that, let's do, we'll pull out the 4 and it'll be 4 times 3 on top, and on the bottom it's 4 times 2, right? So then you can cancel out your 4's and you're left with 3 over 2. Okay, it's the exact same thing. That's all we're doing. Okay, it's just now we have some x's involved. So don't get freaked out by this because you already know how to factor. We did that in Unit 5. And you know how to reduce fractions, so it's just that simple. All right, the last example we have y squared plus 3y plus 2 over y squared minus 1. Okay, now hopefully you remember back to Unit 5, and we're going to do some factoring. So if you look at the top, we got y squared plus 3y plus 2, and that breaks into the binomial. Okay, you got y plus 2 and y plus 1, right? Okay, because 2 times 1 is 2. Let me see a little highlighter here. 2 times 1 is 2, and then you got 2y and 1y makes 3y. Okay, now that's why we spent so much time on Unit 5 so that you can do all this stuff later on. Okay, and then on the bottom, hopefully you realize that this bottom one in the denominator is a difference of 2 squares, right? And you remember how to do that, so that becomes y plus 1 and y minus 1. Okay, and now do we have anything in common? We do, with the y plus 1's, right? Those two cancel out, and then we're left with y plus 2 over y minus 1. And there's your answer. That's it. Okay, so that's all you're doing here. Okay, you're factoring, and then you're finding what's common, and you're canceling them. Okay, it's just that simple. You have a couple try these here. Let's give those a shot, and then come back when you are ready to see if you did it right or not. Okay, so let's take a look at these. Try these. The first one we have 12y plus 24 all over 48y. So on the top you should see that we have a 12 in common, right? So we're going to pull out 12, and you get y plus 2 over, and then 48y. So I'm just going to separate it just a little bit so we can see what's going on. And then you should see that the 12 and the 48, those things cancel, right? So 12 becomes 1 and 48 becomes 4. And so we have y plus 2 all over 4y. There you go. Okay, so let's keep on moving on. So in the second one, 2x squared plus x. So we have an x in common, right? So we're left with 2x plus 1. And on the bottom we have an x in common as well. And we're left with 3x plus 2. And the x's cancel out. So we're left with 2x plus 1 over 3x plus 2. And there you go. Can't do anything else with that. So we are in simplest form there. Alright, let's see if I can move this over just a hair. So I can do this last one. I'm going to blow it up a little bit. And we'll go white with that one. Alright, so on the top we have a difference of 2 squares, right? So that's going to be a plus 1 and a minus 1. And on the bottom, let's see how we figure this one out. We got a 2a and an a, and we know we need a positive and a negative 1 because we got to multiply to be negative 1, and we want the 2 to be bigger. So let's put the negative there, and we'll put the positive there. Alright, and look at that. We now have the a minus 1 and a minus 1. Those cancel. So we are left with a plus 1 over 2a plus 1. And there is our final answer. All right. So that's the basics to simplifying. Hopefully that makes sense to you guys. And next video we'll talk about additive inverses and we'll go from there.